All right, that's time. Good afternoon, everybody. Ooh, you're getting good. You're getting good at this. If we're lucky, next spring we'll actually be able to have the whole class together and we can actually really put the people on the other side of the wall to run for their money. It's awesome. All right. See, I hit the button early this time because I knew every time I hit the button, then somebody shows up. Press it early. So when you come thinking you're late, you'll actually be on time. All right. We've been talking about the SAT, right? And now we get to start the SAT geometry math, the actual content that will be on the every time. Jenny, you gotta check your speakers or something, or your microphone. You keep doing that. At least we know you're here, okay? It's good to make an entrance, okay? So, with that in mind, the geometry math, not the making an entrance, but that's important too. We're going to start laying the foundations of our geometry foray this quarter with, what's that? This is today's work. It's due tonight. You haven't started yet, unless you did do it this morning earlier before class.
Mr. Apple.
No, do it at the end of the day. That's the work for today. I'm going to talk about it. Okay. Now that we're all jumbled up and out of order.
Mr. Apple.
Yes?
You marked me absent Power School for this class.
What? I just updated it. Reload it. Try it again.
All right.
Shouldn't be. Okay. So, where was I? Geometry, right? Here's the thing about the geometry. I've noticed that a lot of the stuff we're going to cover this quarter is not all that new. The concepts, the material, the shapes, the area, perimeter, these ideas, you've done in elementary and middle school before. What's going to be new is the vocabulary and the notation. That's going to be the thing that throws you off the most, I guarantee it. Okay? Because I've done this with students before. They understand what's going on typically. If you sit down and you try to explain, if you just point to the page, be like, oh, it's that one and it goes here, I understand this. It's just describing it, using the proper words and terminology. So that's what we're going to focus on today. You should have started your weekly homework, which is to take notes on sections 1.1, 1.2, and 1.3. Right? Okay, so you were thinking of the notes. Right, no, the notes are due Friday. But you've already done one of those sections. You should have already had notes for 1.1. That's the thing we started with. I gave you my example notes of 1.1, right? So really, you only had 2 sections you needed to do. So if you've already started or even completed those notes, that's great. Make use of them today and refer to those notes. If you haven't, then you'll have to rely on the actual full textbook section itself, okay? Here's what we're going to do. The building blocks of geometry are very simple. Points, lines, planes, everything else comes from that. But it gets very confusing when they throw something like this at you and you're like, plus equals 3 some, right? What does that mean? Well, we got to break it down, right? Mathematicians are as lazy as possible. We've shortened and condensed everything. So we've got to work on parsing the notation. cm, we know now, stands for centimeters. That's a unit of measure. I think we're used to that one. Right? So if it says something equals 3 centimeters, that means it's this big, right? It's that many centimeters long. We're talking about a length here. But what is 3 centimeters long? PS, 2 letters and a bar on top of it. So back from section 1.1, we learned that the basic thing in geometry, the absolute smallest is a single point, and we label it with a capital letter. And you could have 2 points. right? And we could label it with another letter. If that one's A, this one will be Z. Ha, you thought I was going to say B. And you can connect those 2 points with a lovely line, and now you have, it's not a line goes on forever in both directions, right? Now it's a line. You got to put arrows on it. And if I want to refer to this line, I can give it a name. We can say this is line M, and we use lowercase letters for that. Or more commonly, they always start with L, and they use cursive lowercase l for lines. Or we could be very particular. We could give it its full name, right? This is where you like fill in the proper information. The form wants you to put in your middle name, right? Full name, line AZ, but not just any A to Z. We're going to put the symbol for a line above the 2 letters, and that symbol is, these mathematicians were very clever back in the day. They said, what if our symbols for the things are just smaller versions of the actual object? So if you want to say that AZ is a line, you put a tiny little line on it, complete with the arrows. If instead we're only dealing with segment AZ, then our notation is only a segment, right? If we want ray AZ, maybe only that side has the arrow, then make sure only that side has the arrow. And now it's ray AZ. You see how that works? It's kind of nice and clever when you think about it. It's very handy. You can compact a lot of information to a very small amount of space. But then you got to be able to process it and extrapolate out in the other direction. This notation will appear, one, throughout the rest of our book and the rest of our course, but it is also used on the SAT, so you do need to know it at least for that. Any questions so far? All right, they tell us that segment PS here is equal to 3 centimeters long, which means on the handy-dandy provided diagram, here's point P, here's point S, here is the segment in between them. That length there, that much is 3 centimeters worth. I have no idea if this is to scale. Depends, I guess, on how far you've zoomed it on your iPad when you take out your ruler. But there's another interesting thing here. We've got more points on this line, and there's something else. What the heck is all this stuff in the middle? Those tick marks or tally marks are used to indicate things that are the same size. If an object has the same number of tally marks as another object, then it is the same length. So because PS has 2 tick marks and N to P has 2 tick marks, they are the same length. So if this was 3 centimeters, this is 3 centimeters. Right? And now we can use that information. You could then add them together, subtract, all that fun stuff you do with numbers normally, find the length of any portion of that line that they might ask you for, right? Fairly handy. I also want to call your attention to rays, because rays can be tricky. This is ray SQ. Notice the little arrow there. I know it's a little tough to see on the copy of a print you have available. This is also ray SQ, although we would probably say it's ray QS because it starts at Q and goes through S. Q is the end point, and the arrow is on the S end. So on the symbol, the arrow is on the S end, okay? So watch out for that. Make sure your symbols are going in the right direction. We can reverse it. Other things to watch out for, right? You need to understand what a congruent segment is. Congruent is our new geometry term for same size, same shape. It's kind of like equals, but not quite. Shapes are congruent, numbers are equal. More on that later. For 12 and 13, you're going to need to know what collinear means. It's there in the name. Co, of course, means with, same as Spanish, con, with line, the same line. They're on the same line. So you're just going to sketch some points, no 3 lines of which are collinear. So you don't want 3 of these points to end up on the same line. So if I make any 2 and draw a line between them, don't put the 3rd one on the line. It's got to be out there somewhere. Okay, so you need to figure out how you can do that for 6 of them. You can sketch this. Sketch is not precise. A sketch is not exact. Do not measure a sketch. If you're doing this by hand with a pencil, just freehand, there, circle, and some points of it, whatever. Close enough, okay? You can do this using the Kami notation tools if you want to go digital. That has enough tools to complete this because you only need to be able to draw points and lines. That's it. Well, more properly, line segments, right? That's enough to create the sketches for these. Similarly, coplanar, just like collinear, except now it's with a plane, on the same flat surface. So if this box was in fact a room, every surface would be a wall or the floor or the ceiling. So you're looking for which points are on the same wall, right? That's coplanar. Questions so far? All right, let's jump ahead. The next page goes to section 1.3, and this introduces a lot of the angle vocabulary and angle relationships. So here you're going to be matching the diagram up top with the particular term underneath. Find the picture of vertical angles. Find the picture highlighting the right angle. Okay? Remember what obtuse and acute angles are. Obtuse is greater than 90. It's the big ones. Acute is the small ones, less than 90. Okay? It's cute and adorable. Totally works. Got to remember what complementary angles are. What's a linear pair? If you don't know, look that up. Find it. It is more important right now for you to be able to identify them from the picture and associate the term with your own picture than it is to write out a formal definition with words. I'd rather you treat this visually because that's how it's going to appear on most tests. Here's a diagram. You need to see it and recognize, these two are vertical angles, and vertical angles have this relationship, okay? And understand what the measurement correlation between those two is. Similarly, the SAT might throw out and it'll describe something and say, hey, here's the setup, A and B are vertical angles. And you need to create a picture in your mind or maybe sketch one out on the page real quick. Okay, vertical angles, that means they're going to be set up like this and this. Right? And know what that looks like. That's more important to me than writing out a definition. Right? Match the pictures. Any questions there on the angle stuff at this point? Okay. Number 10 then brings some actual numbers into the complementary relationship. So be able to work with those. Now at the bottom here, we've got some more sketching and labeling to do. Now you're going to make your own fancy diagrams. They don't have to be that neat and tidy. That's why we introduce these symbols and this notation so that you can turn any run-of-the-mill sketch into a proper labeled diagram, and anyone can look at it and understand all of the same information, right? So here once again, lowercase cursive L for lines. And then mathematicians said, hey, you know what we have a lot of? Parallel and perpendicular lines. If only there was a shorter way, because this word is a lot of letters to write every darn time. And half the time, I can't remember how to spell it correctly. And so once again, they took the actual picture, shrunk it down, and said, that's the symbol. So we took the best symbol for parallel lines is literally a pair of parallel line segments. Can't get much clearer than that, can you? Same with perpendicular lines. These two segments are perpendicular to each other. We were going to go with a full-on four-way intersection, but that symbol was already taken. Darn you, addition. So instead you get this upside down T. It still gets the same idea across. Right? So from reading this, you should be able to draw your three lines and how they relate to each other. Look at 12. 12's got a lot of interpretation going on here. P and Q, there's only a flat line above it. PQ must be a segment. PR, there is a little arrow on the end. I know it's hard to see here. I apologize for that. That's why I've highlighted it for you now. That means it's a ray with the arrow on the R end. P must be the single point, end point of that ray. And those two are perpendicular to each other. So make sure you indicate that. There is a symbol you can use on a diagram that shows if an angle is supposed to be a perfect right angle or not. You do not need to get out your protractor and measure and make sure you've drawn your picture perfectly. I mean, I can cheat a little bit because this has some snappy line features, right? But if you're off like that, is that quite 90 degrees? It's close, but there's a way, there's a mark I can put in this corner to show, oh, I meant for that to actually be perfect 90 degrees. Look that up. If you can't find it already, hint, hint, it is up here somewhere. Shh, don't give it away. But yes. All right. And then finally, do note on number 12, this is PQ, this is PR. They've repeated a letter. They both have the letter P in them. You can only use each letter once per diagram. So for your diagram on number 12, the letter P has to be labeling the same point. That means that point exists on this segment and on this ray. Make sure your diagram reflects that. Okay? They're going to have to learn to share. When you move on to number 13, then you can reuse the letter P because it's a totally different universe scenario happening there. All right? One letter per point in a diagram. And 1 point per letter. All right, speaking of 13, 13 adds all kinds of more fun stuff. Now we've got 3 letters in a row. Oh my goodness, totally unprepared for 3. 1 letter labels a point. 2 letters defines a line or line segment or ray, right? Some version thereof. 3 letters creates a plane or, in this case, an angle. And we had to put the angle symbol in front of it. Look, it's just a little crooked thing that looks like an angle. Right? That means this is angle BAC, not the whole plane. BAC is written in a very specific order. Just like with rays, the order matters. You have to go B, then A, then C. A is in the middle. So on my diagram, point A must be in the middle. It must be between B and C. That creates it as the vertex angle or vertex point. I can swap B and C around. I can make this one B and that one C. That's okay as long as I can follow in order B, A, C and trace that out just that way. So if A is in the middle, A has to be in the middle. Make sure you're doing that. Now here's where we get back to congruence versus equals. Here is a congruent symbol. It looks like equals, but it's got the extra squiggle over it. That means this is congruent. Shapes are congruent. Congruence means same size and same shape. Numbers are equal. So if you ever see the equal symbol, they better be between 2 numeric quantities. This says CX. That's 2 letters. I thought that was supposed to be a line segment. Ah, but do you see the line segment symbol above them? No, you do not. So CX here is not indicating the segment itself. If there is no symbol above it, just the letters is referring to the distance between C and X, or the length of CX. Okay? Sometimes we might even indicate, you might see a little lowercase m, the measure of segment CX. Right? That would mean the same thing. And we got even shorter. Just the 2 letters indicates the length. So if it's a length, that's meaning it's 7 centimeters or whatever, right? Length is a number. Numbers then can be equal. Okay? Numbers are equal. Shapes are congruent. Is it strictly necessary? Not really. We know what you mean, usually. If you write the wrong symbol, I will probably still understand what you're getting at. But you need to be able to recognize them because they will be separated on official documentation and on the SAT, and you need to know what they're talking about. This gives you a big fat hint which symbol they're using as to what you need to find. Do I need to interpret this as a triangle, or can I just find the length? Right? So it does help. Okay. Any questions there? Okay, don't see any online. Your task then for today is to finish answering these questions and exercises here from both pages. Again, make use of your notes or the textbook sections themselves as necessary. Look anything up that you need. If you do have questions, feel free to ask me. I'd be happy to help you out. Next week, we will rush through the rest of Chapter 1 here in a similar manner. We'll hit some of the highlights and really lay down the foundation of all the vocabulary, make sure we're all on the same page. And when I say pentagon, the same picture pops into everybody's head. Okay? And then we can really get into the nitty-gritty and deal with measurements of angles and parallel lines and all that good stuff. All right? So you've got the rest of the period to work. I'll leave you to it.